Hi everyone, we've got another math lesson for you today. So like usual, we'll start off with some of our fluency. So yesterday in fluency, we were looking at what happens when we times a number by 1. And then we were looking at how that changes when I then multiply that same number by 10. So for example, the number 2. Well, we know that anything multiplied by 1 is just itself. So then my product is the same as my first factor. But let's say I'm now choosing that same number, and then instead of multiplying it by 1, I'm now multiplying it by 10. Well, you can see what's changed here. I'm no longer timesing it by this 1-digit number. I'm actually timesing it by a 2-digit number. And this is a 2-digit number with 0 ones. So what's happening is our 2 is getting 10 times bigger, and we show that by using our starting number and then putting that 0 on the end to show that it's getting 10 times bigger. But what we're going to look at today is what's actually happening to those digits as they get 10 times bigger and where that 0 comes from. Why do we have to add that 0? Well, let's have a look. Let's take the number 3, for example. There's the number 3, single digit all by itself. So that just means 3 ones. And as that gets 10 times bigger, what happens is it moves from the ones column into the tens column. So when a digit gets 10 times bigger, it moves from the ones column into my tens column. But if I write that 3 times by 10 equals 3, that's not right, because that 3 by itself is still a single digit, and that's not showing me that that 3 is in my tens column. Remember, to have a digit in the tens column, you must have 2 digits in that number, and the 3 being there is very different from what the 3 means when it's in this column, because remember, 3 tens is much, much bigger than 3 ones. So let's go back to the beginning. 3 all by itself, I'm going to times it by 10. So when I times a number by 10, the digits move into the next column on the left. But that then means that our ones column is now completely empty. So what I need to do is I need to put another digit here to stop my 3 from falling back into my ones column. So which digit do I have that represents the fact that there is nothing here? Lovely, well done. 0 is the digit that represents nothing being there. So that 3 that was in our ones column moved up to our tens column. So now I've got the number 30. I had to add my 0. And when I have to add my 0 to stop my 3 from falling back, I call this a placeholder, because it's holding my 3 in its place in the tens column. So let's try that again with a different number. Let's try 4. So 4 all by itself just means 4 ones. And when I times that by 10, so now we're multiplying 4 by 10, the digit has to move from our ones column into the, that's right, it's got to move into the tens column. But what happens is that our ones column becomes empty. So what digit do I need to put here to stop my 4 from sliding back into my ones column? Well, remembered, I need to put a 0 there, which is called a placeholder, because without it, our 4 would not stay in the tens column. So that then means my answer is 40. Lovely. Let's try another example. Let's do 5. So here we go, got the number 5. 5 by itself, single digit, that means 5 ones. And then when we times by 10, that 5 moves from my ones column into the, lovely, it moves into our tens column. What happens here? Super, I need a placeholder. So I need to add my 0. So 5 times 10 is 50. What I'm going to do now is I'm going to put the number 6 in there. And I would like you to pause the video and have a go at working out what would happen to our number 6 when we times it by 10. Super, well done for having a go. Let's go through the answers then. So 6 times by 10. Well, when I times by 10, my digits get 10 times bigger. So it can't go in the ones column anymore. It's too big. So I have to move it into my tens column. But we can't leave our ones column empty. So I need to put a placeholder, which is a 0. So then 6 times by 10 becomes 60. Well done. Why don't you have a go? Oopsie daisy. Why don't you have a go at working out 7 times 10, 8 times 10, and 9 times 10 by pausing the video, and we'll go through the answers in a second. Lovely. So let's have a look at 7 times 10. Well, 7 times by 10 is too big for my ones column now. So it has to go into my tens column when it gets 10 times bigger. But I can't leave my ones column empty. I need a placeholder, which is a 0. So 7 times 10 is 70. Well done. Let's try the number 8. So 8 all by itself is a single digit number, which represents 8 ones. When it gets 10 times bigger, my 8 has to move into my tens column. Well done. But I can't leave my ones column empty, so I have to add a 0. Well done. And last but not least, the number 9. So number 9 on its own, single digit means 9 ones. When I times it by 10, it has to move into the, fabulous, it has to move into the tens column. But I can't leave my ones column empty, because otherwise my 9 might sneak back in. So I need to put a placeholder, which is our 0. Excellent, well done, year 2. So 9 times by 10 would be 90. Tomorrow we're going to look at the same thing, but with 2-digit numbers. So maybe you could start to have a think, what would happen if I tried to do this with a 2-digit number? Just have a think, but we'll go through that tomorrow. Well done, everybody. So yesterday we started to look at arrays, and arrays helped us to work out that multiplication was commutative. And that means that my 2 factors could be in any order and I would still get the very same product. So we're going to carry on looking at this idea of commutativity today. So here I've got a representation. I've got 2 groups, and inside each group I've got 4 cakes. So I've got 2 groups of 4. So let's have a go at working this out. 2 groups of 4 equals, okay, so then that means that I've got 2 groups, so I need to get my 2 fingers. That means I need to count in my 4s. But I don't know how to count in my 4s yet. I haven't learnt that. So what do we know that could help us solve this equation? Let's have a look. Did you say this? Did you say that we know multiplication is commutative? Lovely. So let's have a look at that in an array. 2 groups of 4. Well, I've got 1 group of 4 here, 2 groups of 4 here. So I've got 2 groups of 4, which is what we're seeing there. But remember, multiplication is commutative. So what I could do is I could also, instead of grouping it going across, I could also group it going down like this, which would then mean that instead of having 2 groups of 4, I would actually have 4 groups of 2, and it would give me the same answer. So let's have a go at working that out. 4 groups of 2, well, that means I get 4 fingers to show my 4 groups, and I skip count in my 2s 4 times. So we go 2, 4, 6, 8. And our product for this question is the same because our factors are the same as the one here. They're just in the opposite order as each other. But I'm going to show you something different today. It's still looking at this idea of commutativity, but we're going to have a look at what happens when we get a problem like this, and a different way that we could look at actually look at multiplication. Okay, so far we've actually been looking at multiplication as equal groups of something. So for example, the representation that we've just looked at, I've got 2 equal groups of 4. But we said that that was problematic because we don't yet know how to count in our 4s. That was quite tricky. So instead of looking at it as 2 groups of 4, where our multiplication symbol looks at it as groups of, remember that code word, it does still mean that, but we can also look at it in a different way. So let's have a look here. Instead of actually moving the digits around, what I could do is I could say, well, instead of this, meaning our groups of, what I could do is I could put it with my second factor and say, actually, instead of having 2 groups of 4, maybe I could just have 2 4 times. So if we look at that in this example, that means I've got 2 cakes 4 times. So that would then mean that I've got 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. Now we know that we could have said that by writing it commutatively and saying 4 groups of 2. But instead, because we know that it's commutative, we could just say 2 4 times. And that would show that instead of grouping it like this in our 2 groups of 4, we then look at it in groups of 2 instead. So that means that even if there are 2 equal groups, we can still use our 2 times tables, our counting in 2s, to work it out. Let's have a look at this one then. What have we got here? Well, I can see that I've got 1, 2, 3, 4, 5 groups. I've got 5 groups of 1, 2, 3, 4, 5, 6. I've got 5 groups of 6. So that means I do my 5 groups and I get ready to count in 6. Oh wait, I don't know how to count in my 6s yet. I haven't learnt it. So let's think about commutativity. Well, we know that if we put that into an array, instead of grouping it into 5 groups of 6 like this, 1 group of 6, 2 groups of 6, instead of doing it like that, we can group it going downwards instead. And I don't even need to do all of this to know what it would give me, because I know multiplication is commutative, so that means that my factors can be written the other way around as well. So if I were to continue doing this, I would get 6 groups of 5. And now we can work that out because I can count in my 5, so I get my 6 groups, and I count 5, 10, 15, 20, 25, 30. What would my product be for this calculation then? That's right, the product would be 30, because commutative means that when my factors are switched around, I get the same answer, I get the same product. Lovely, but remember, we can still use our 5 times tables even when it's written in this order, because we can also, instead of looking at this as groups of, we can look at it as 5 6 times. So as you can see, what I've done here is instead of grouping them into 6 stars, I've gone over with my pen and instead I've put them into groups of 5 stars. So I've now got 5 stars 6 times. So I didn't even need to change the order of these because I can look at multiplication in a slightly different way and say that I've got 5 6 times. So just like before, I count 5 6 times. So I've got 6 fingers, 5, 10, 15, 20, 25, 30, which we just did. So that means that if there are 5 equal groups, like it is here, even if there are 5 equal groups, I can still use my 5 times tables to work it out. Let's have a look here then. I have got 2, 4, 6, 8, 10 groups there. I've got 10 groups of, how many apples are inside each one? 1, 2, 3, 4, 5, 6, 7. So I counted 7 apples in each group. So that means I've got 10 groups of 7. So that means I've got 10 groups and I need to count in my 7s 10 times. Oh wait, I don't know how to count in my 7s yet. That's too tricky. So instead, we could either look at it like we did yesterday and we could look at it in terms of commutativity, and instead of grouping it like this into our 10 groups of 7, we could rearrange our factors to say that instead we've got 7 groups of 10 and work out our answer that way. But we're going to look at it from a different perspective where we've still got 10 equal groups. And instead of saying 10 groups of 7 and counting in our 7s, we could say we've got 10 7 times. This is why we call it our times table, because we've got numbers a certain number of times. So I could say, instead of saying 10 groups of 7, I could say that I've got 10 7 times, in which case I would get my 7 fingers because I've got it 7 times, and I would count 10, 20, 30, 40, 50, 60, 70, which would be my answer. So even when I've got 10 equal groups like here, I can still use my 10 times table. So that's what we're learning today. So I've got some word problems for us here. There are 5 children. So each of these children represent a group. And if I want to, I could even draw that out. It's a bit tricky for me, but sometimes trying to represent, especially a word problem, can be really helpful. So there are 5 children. Oh, this is too difficult. I'm just going to have to draw circles. They're just heads of children now. There we go. So there are 5 children. 1, 2, 3, 4, 5. Each child has 4 conkers. Now, conkers are these wooden round things that come from trees. So each of these children have got 4 conkers. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, what I could do is I could say, well, I've got 5 children, and then count in my 4s. But that doesn't sound right because I don't know how to count in my 4s yet. So what times table do I know that can help me answer this question? That's right, there are 5 children, and I do know my 5 times tables. So even if there are 5 equal groups, I can still use my 5 times tables because I can say that I've got 5 4 times. So I would get my 4 fingers and I would count 5, 10, 15, 20. So in actual fact, I can use my 5 times tables to help me here. So I've not written the answer because the question doesn't ask me for the answer. The question asks me which times tables I can use. So let's have a look at this one then. there are 2 teams. There we go, got 2 teams. Each team has got 12 bean bags. So we've got 2 teams and each of these teams has got 12 bean bags. How many bean bags are there all together? Well, I've got 2 teams and each of them have got 12. That means I've got 2 groups of 12. So I've got 2 groups. Oh dear, I don't know how to count in my 12s yet. So what times table do I know that can help me calculate the answer? That's right, I know my 2 times tables. So even if there are 2 equal groups, we can still use the 2 times tables because I will have 2 12 times. So I know my 2 times tables will help me answer that question. Right, 5 children again. 5 children each have 3 balloons. So 5 children, they've got 3 balloons each. How many balloons are there all together? So I know I've got 5 groups of 3. 5 groups of 3. Well, I can't count in my 3s quite fluently yet. If you can, super, you could do it like that. But if you're more confident with your 5s, then you might say instead that you've got 5 3 times. So then you would count 3 times 5. 5, 10, 15. So my 5 times tables will help me out here. Let's have a look at our last one then. 10 children each have 3 meatballs on their plate. How many meatballs are there all together? Well, I've got 10 children and they've got 3 meatballs each. So that means that I've got 10 groups of 3. But I'm not 100% confident counting in my 3s yet. So instead, I could say that I've got 10 3 times. And then I would say that my 10 times tables would help me answer that. So even when I've got 10 equal groups, I can still use my 10 times tables to help me out. Okay, the last thing then before we go on to our independent practice. I have got here some times table expressions. Remember, they're expressions because they don't have a equal sign. Well remembered. So I've got 5 times 4. So remember, I could say I've got 5 groups of 4, or I could say that I've got 5 4 times. So would my 2 times tables help me out here? No. Would my 5 times tables help me out here? Yes, they would. Well done, because I've got 5 equal groups. And we just know from doing this that if there are 5 equal groups, we can still use our 5 times tables to help us. There we go. About this one then. 2 multiplied by 9. So I could say I've got 2 groups of 9. Or I could say that I've got 2 9 times. So would my 2 times tables help me answer this question? Yes, they would, because I've got 2 equal groups. And remember, when I've got 2 equal groups, I can still use the 2 times tables. What about this one then? 7 times 5. So I could say I've got 7 groups of 5. Or I could say that I've got 7 5 times. Would my 2 times tables help me answer this question? No. Would my 5 times tables help me answer this question? Yes, it would. Fantastic. Remember, I've got 7 groups of 5. So that's just the original way that we learned our multiplication. 7 groups counting in our 5s. Let's do this one before you have a practice by yourself. So 10 times 12. So I could say I've got 10 groups of 12. Or I could say I've got 10 12 times. Will my 2 times tables help me answer this question? No. Will my 5 times tables help me answer this question? No. Will my 10 times tables help me answer this question? Yes, it will. Well done. So what I want you to do is I want you to have a look at these expressions that are left, and I want you to tell me where you think that they will go. And then when you've decided on a place for all of them, you can play the video again and we'll go through it together. Super, well done for having a go. So 6 times 2. Well, what I'm noticing is that if 2 is a factor, then I can use my 2 times tables. And it doesn't matter whether I've got 2 equal groups, because like we worked out here, even when I've got 2 equal groups, I can still use the 2 times tables. Or if I've got groups of 2, I can use the 2 times tables. So if 2 is a factor, I can use my 2 times table regardless of which position it is in. So this actually has 2 as a factor. So then I could use my 2 times tables to help me solve that. Is 2 a factor of this expression? No. So I can't use my 2 times tables to help me with this because it's not one of my factors. What about my 5 times tables? Would my 5 times tables help me here? No, it wouldn't. What about my 10? Lovely. So 10 is a factor in this expression. So when 10 is a factor, we can use our 10 times tables. It doesn't matter which order it is in. What about this one then? 12 times 5. Which times tables would I need to use to help me? Perfect. I'd need to use my 5 times tables because 5 is a factor. So when 5 is a factor, it doesn't matter whether I've got 5 equal groups or whether I've got 5 objects inside each group, I can still use my 5 times tables to help me. What about this one? Well done, I can use my 2 times tables to help me out there. What about this one? Super, 10 is a factor, so I can use my 10 times tables. And what about this one then? That's right, 5 is a factor, so I can use my 5 times tables to help me. Super, so it's your turn to have a go by yourself now. Remember, you've got 2 sheets to complete at home. Just 2. You don't have to start from circle, but if you want to, that's fine. Choose the sheet that is the right level of challenge for you. So you can either access the sheets on the home learning section of the Byron Wood website, or what you can do is just pause the video on whichever questions you're doing and write down the answers on a sheet of paper. So here, for example, I've got 1, 2, 3, 4, 5 groups. So I've got 5 groups of 1, 2, 3. I've got 5 groups of 3. So I've got 5 groups of 3. I'm not quite confident counting in my 3s yet. So what I could do instead is I could say that I've got 5 3 times, in which case I know that the answer would be 5, 10, 15. There we go. So that's what you need to do for this sheet here. For our semicircle sheet, you have got 1 equation written, and what you need to do is you need to draw 2 different representations of that equation. So remember, the 2 ways that we've been looking at are saying groups of, so I could say I've got 5 groups of 3, in which case I would write, and you could draw X's, you could draw triangles, you could draw flowers in your groups. It doesn't matter as long as your groups are equal. So I could draw 5 groups of 3 like this. So you don't have to watch me do this forever. I'll just pause the video and I'll do it super quick. There we go. Hopefully yours are much, much neater than my horrible ones. But I could say on the one hand, I've got 5 groups of 3 like we were looking at. Or on the other hand, I could say that I've got 5 3 times. In which case I would have 5. So 1, 2, 3, 4, 5. I would have 5, and I would have 5 3 times. So once again, I'll pause the video, draw it, and you can have a look at what that would look like. There we go. So I can see that for this one equation here, I've actually got two different ways of representing it. I could say that I've got 5 groups of 3, or I could say that I've got 5 3 times. So that's what you need to do for the rest of that sheet as well. The triangle sheet then is an opportunity for you to match up the commutative expressions. So it might be helpful for this one for you to write out what's being represented in a way that you understand. So if I were you, I would choose one way of saying it. And if you're more comfortable with saying groups of, then you could say here, I've got 1, 2, 3, 4 groups of 2. 4 groups of 2. So let's have a look then. Here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 groups there. So that means 10 would be a factor. And there's no way that 10 is a factor here, so it will not match with this one. So what have I got here? Oh, here I've got 2 groups. So I've got 2 groups of 4. So actually I can see that both of these use the same factors and there will be the same total amount of objects in each of those representations. So you need to do that for the rest of that sheet. And then the square sheet. This is for those of you that are working at greater depth for year 2. So do not do this sheet if you are finding this work tricky. If you're finding this work very easy, then have a go at this challenge sheet. So what you need to do is you need to fill the box here with the appropriate symbols. Remember, we've got the more than, less than, and equal to symbol. And remember, with these symbols, the larger side of that symbol faces your larger number, or in this case, your larger equation. And the smaller side points to the smaller equation. So let's have a look. I've got 4 times 5. So what I could say is I've got 4 5 times, or 4 groups of 5. So 4 groups of 5. And then on this side, I've got 6 groups of 5, or I've got 6 5 times. So for each one, what you need to do is you need to make sure that the factor that is in both of them is in the same place. And use that same consistent way of saying it. So remember, if the times table that you're looking at is here, you need to do groups of. If it goes first, then you need to look at it as equal groups, and you've got something so many times. So let's have a look. 4 groups of 5 or 6 groups of 5. Well, I know for a fact that they're not equal, because if they were the same, they would both have the same factors on both sides. So it's definitely not equal. So which one would be more? 4 groups of 5 or 6 groups of 5? Well, 6 is a bigger number than 4. So if I've got 6 groups of 5, then that means that whatever answer I get here would be bigger than whatever answer I get for here. So that means that this expression is much bigger than this one. Okay, so that's what we're doing for this sheet down here. Once again, well done everybody. That was some tricky stuff today, and we're nearly getting through and finished the multiplication. We've got just a couple more lessons this week, and then we'll be going on to some division. So well done, superstars. See you for another lesson soon. Bye.